Hi first graders, I'm here to teach you math lesson 7-7. We skipped math lesson 7-6 because it was a materials exploration that we would have done in class, but we're not going to do that one through a computer screen. So we're working on lesson 7-7, which is all about defining and non-defining attributes. So last time when we talked about shapes, we did talk about the word attribute, and we decided these were the attributes we discussed when we were working with these shapes that I have. So we were discussing that these shapes had different colors, different shapes, different sizes, and some of them were thick and some of them were thin. So today we're going to add these new words, defining and non-defining attributes. So my sign back here, our goal is saying that the students can know the difference between the non-defining and defining attributes of two-dimensional shapes. So that just means shapes that we can draw on our paper. So not like the shapes that I was just holding up that we can touch and feel. We're just going to look at the shapes that we draw right flat onto paper, okay? So to kick this off, I want you to take a peek at these two shapes Miss Lumsden drew. I want you to think, how are these shapes the same? And how are these shapes different? All right, so you may have seen that both of these shapes have 1, 2, 3 sides. So they both have 3 sides. They look about the same size. This one might be a little taller. And they both seem to look like triangles, right? But there's one huge difference, and you can see this one appears to be broken. And it's not fully touching in like a triangle that we know to look like. So when this shape looks like this means this shape is open. It looks like it has an open door. And we don't want open shapes because it doesn't keep them closed, because this one is closed and this one is open. And we want our shapes to be closed so that all their sides touch each other and they can be a complete shape. So this one over here is actually not a shape because it is not closed and it's not touching. So really right now it's just some lines. It's not fully a triangle because of its open top. So today we're going to learn about how these different attributes, like the ones I just talked about, it being open and closed, and a few more, are either defining attributes of a shape, which means these shapes have to have those qualities, or they're non-defining, which means a shape could have them, but they don't need to have them in order to be a triangle or a rectangle or any type of shape. Okay, so we're going to keep it going with the triangles, and we're going to take a peek at these triangles that Miss Lumsden drew. And again, I want you to look at them and see what you notice, what's the same, what's different about these shapes. Okay, so hopefully we have all noticed and we all agree that these are all triangles. We know triangles have 3 sides and 3, that's a new word, I don't know. We know that they have 3 points is maybe what you learned to call them in kindergarten. We're going to use a new word called vertex for the points. So Miss Lumsden's going to label this a little for us. I'm going to write side. And then when we're looking at the points or the corners of a shape, we're going to be calling that a vertex. So you can see that we have sides, 3 sides, and these are vertex. So if there's more than one, we call them vertices. It's kind of some big new math words we're learning today. So when we're looking at our shape, we can see that this one has 1, 2, 3 vertices, 1, 2, 3 vertices, 1, 2, 3 vertices. And then we could all see they have 3 sides, 1, 2, 3, 1, 2, 3, 1, 2, 3. So in order to be a triangle, those are 2 of the things that you must have. You must have 3 vertices and you must have 3 sides. Are any of these shapes open, like this first one that I showed you? Doesn't look like any of them are open. They're all closed, so we know they all can be a shape because they all have those touching edges. So when I'm telling you that I know these triangles have to have 3 sides and have to have 3 vertices, those are the defining attributes. You have to have that in order to be a triangle. So we're going to work on filling out this together. And we're going to use these triangles to fill out this chart. So you can see on one side, Miss Lumsden wrote the defining attributes. And I started the sentence with all triangles. And we're going to write down what we think all triangles need to have. Those are the defining attributes of a triangle. And then on this side, we're going to write what some triangles might have, but they don't need to have it in order to be a triangle. And we will fill out that side as well. So let's start again. Miss Lumsden just told you, I'm starting it off pretty easy because I told you already, we know that these are all triangles because they have 3 sides and 3 vertices. So I'm going to add that to our list. That all triangles have exactly 3 vertices. If it had 4 vertices, would it still be a triangle? Nope. To be a triangle, it has to have exactly 3 vertices. All right, I'll show you that I added that sentence right there. All triangles have exactly 3 vertices. And the other thing we know all these triangles have is they have 3 sides. Now, we're still agreeing that these are triangles, even though maybe this one is angled different or these are shaped a little different, right? They don't look exactly the same triangle, but they still have 3 sides and they still have 3 vertices. So we know they are, in fact, triangles. All right, so the other last thing that we know that makes these triangles is that they don't look like this. They don't have open sides. So that means that this shape is closed. They're all closed shapes. None of them have gaps to make them not be a full closed shape. So that's the last thing I'm going to write on my list is that it's closed. All right, let's check it out. So these are the defining attributes of a triangle. All triangles, if it's a defining attribute, it means the triangle has to have it. All triangles have exactly 3 vertices, which remember are the corners or the points. They have exactly 3 sides and they are closed. Okay, so those are the things a triangle must have. So I'm going to draw a few right now and I want you to tell me yes, well, you can't really tell me, but maybe you can show me with your thumb or show your parents. Yes, a triangle, or no, not a triangle. We're going to play that game after we finish our chart here. Let's actually finish what we're doing for non-defining. So let's look back at these triangles and see what do some of these triangles have that they don't need to have to make them a triangle. So we're looking at this. You can see that maybe this one is a little bigger and this one's a little smaller in the corner. So do triangles need to be the same size? Does it matter what size the triangle is? If the triangle has 3 sides, 3 vertices, and it's closed, we don't care how big it is. We could have a triangle that looks super duper tiny like this one. But it has 3 sides and 3 points and it is closed, so it is a triangle. So some triangles might be different sizes. And that's okay. It doesn't really matter what their size is as long as they have those other 3 defining attributes. All right, what about all triangles need to be orange? Do all of our triangles need to have this orange shade on them to be a triangle? No way. We know triangles could be any different color. So we'll add that to our non-defining list is be different colors. All right, well, what else do we see on this that maybe it doesn't need? Polka dots. Do triangles need polka dots? They don't. So they could have different patterns. This triangle here, Miss Lumsden could add some stripes. Is that still a triangle? It's still 3 sides, 3 vertices, and it's flat. I just added stripes. So they could have different patterns. You could draw different patterns in your triangles, and they can still be triangles. All right, and the last thing that we kind of already touched on is these triangles are facing different directions, right? So like the flat side doesn't always have to be at the bottom, as you can see, or it doesn't have to have a point at the top. You could turn the triangle any which way and it's still a triangle. So they could point in different directions. All right, let's check out this list. These are the defining attributes that all triangles must have. So to be a triangle, you must have exactly 3 vertices, exactly 3 sides, and it must be a closed shape. But these are non-defining attributes, and these are going to be the same for any shape that we talk about today. Any shape could be a different size. Any shape could be a different color. Any shape could have different patterns. You could decide how to draw and fill in your shape any way you want. And your shape can point any direction. It doesn't matter if it looks flipped upside down to you. It is still that shape if it has these defining attributes, okay? So I said we're going to draw a couple triangles here and see. You're going to decide, yes, they're a triangle, or no, they are not. So think about this list. Does it have these 3 things? These are the non-defining, so you don't really care if it has these. You just want to make sure 3 sides, 3 vertices, and it is closed. So here is the first triangle. Yes or no, this is a triangle. What do you think? Does it have all 3 of what we need? I see 3 sides. I see 3 vertices. But is my shape closed? No, I didn't finish that line, so that is not a triangle until this shape gets all the way closed like this. And now it is. All right, tell me if this is a triangle. How about this one? Yep, it sure is, because it has 3 sides, it has 3 vertices, and it is a closed shape. Does it matter I scribbled it gray? Nope, that's a non-defining. That means it doesn't matter if it has it or not. All right, let's do one more triangle. Tell me, yes, this is a triangle, or no, it isn't. Check that out. Is that a triangle? What do all triangles need? Exactly 3 vertices. Let's count. 1, 2, 3, 4. Oh, exactly 3 sides. 1, 2, 3, 4. Oh, is this a triangle? Nope, it has too many sides and too many vertices. We crossed it out. All right, good job, friends. So we're remembering, let me show this one last time, that we are looking at the defining attributes of shapes, which means it's something they all have to have. Or we're looking at non-defining attributes, which they could have, a triangle could have these, but they don't need to. So in closing, I want you to maybe think if you could fill out a chart just like this about rectangles. What would be the defining attributes of a rectangle? What does a rectangle need to have to be a rectangle? All right, friends, I'll talk to you soon. Bye.